We introduce differential operators in this section. We know dy dx stands for the first derivative of y with respect to x. And to rewrite this in a different form, we use what we call a differential operator dy. So d is the differential operator. So if we would like to find, so dy, it works exactly the same way as dy dx. So that's the derivative of y, dy derivative of y. So if I want to find derivative of x squared, that would be d of x squared, which is 2x. So another example, derivative of a e bx, that would be a b e to the bx. So what the differential operator does, it transforms a function into another function, as you can see, into a new function. So if I want to look at the second derivative of y with respect to x, that's the same, can be rewritten as d squared y, which is d dy. So what the operators here, or those differential operators, what we can do, we can apply them to differential equations. So if we have a differential equation a y double prime plus b y prime plus c y equals g of x, we can rewrite this using differential operators as a d squared plus b dy plus cy equals g of x. Notice on the left hand side I can factor y out, so ad squared plus bd plus cy equals g of x. So if we let ad squared plus dy plus c equals L, then we obtain L of y equals g of x. L of y. So this previous equation can be written as L of y equals g of x. As an example to this, let's say I want to transform the differential equation y double prime plus 3y prime plus 2y equals 6x minus 5 using a differential operator. To do so, this can be written as d squared plus 3d plus 2 all times y equals 6x minus 5. If you want to move further with this, you can factor actually this expression d squared plus 3d plus 2 as d plus 2 times d plus 1, y equals 6x minus 5. From the differential operator, we introduce what we call annihilator operator. Annihilator operator. So if L is a linear differential equation, or differential operator, sorry, and y equals f of x is differentiable, so that L of y equals 0, then we say then L is annihilator of f. Annihilator of f. The annihilator operator also, or the differential operator, is also linear. So you can if you have f of x or even a plus b g of x, you can get this as a d f of x plus b d g of x. It's linear. So back to that annihilator thing. If we have y equals k as a function, then dk is 0. If I do twice x, that means you do it the first time, which gives us 1, and the second time it gives us 0. So we say d squared is the annihilator of x. Whatever makes that function or transforms that function into 0 all the time, that's called annihilator. So d squared is the annihilator of x. D is the annihilator of k. So if we would like to find a differential operator differential operator that annihilates the equation 2 minus 6x squared plus 3x cubed. How do you do that? Well, notice for a first degree, second degree annihilator took care of it, d squared. For a third degree, I'm expecting, and we can prove that d to the fourth would be the operator. So if you do this 4 times, that will go down to 0. So the differential operator would be d to the fourth. D to the fourth. So now this is a polynomial in general to annihilate a polynomial of degree n minus 1. We use d of n. So it's one more the polynomial, the degree of the polynomial. So we can say the annihilator or the operator d to the n annihilates each of the functions, each of the functions 1 x squared all the way to x to the n minus 1. So this is for polynomial functions. For exponential functions, e to the alpha x, if it's repeated, e to the alpha x, e to the alpha x, x squared e to the alpha x, x to the n minus 1 e to the alpha x. We use the operator d minus alpha to the n to annihilate the functions up here. Find an annihilator operator for, let's say, e to the 6x to 6e to the 2x minus 5x e to the 2x. To do this one, what do we do? What do we got here? We have, if you compare this to the previous, this looks like this. So alpha is 6. And n, this is n should be, because this is the same as x to the 0 e to the 6x. So n is always 1 more than this exponent. So n is 1. So d minus alpha to the n, d minus 6 to the first power. So d minus 6 e to the 6x. So what happens here is d to the e to the 6x minus 6e to the 6x. And this gives us the derivative for this is 6e to the 6x minus 6e to the 6x. That gives us 0. That's what we need. So this would be the annihilator operator, d minus 6 to the first power. For the next one, there are 2 of them. And the way this works is, not 2 of them, 2 expressions here. The way it works is we have d minus alpha here, as you can see, it's 2. It's 2. But it's repeated. There's a repetition here. Do you see the x? So there should be a square here. So that would be the annihilator operator. Since, again, if you do d minus 2 square of all of this, that should give us 0. And you may try it, like you can expand this d squared minus 2d 4d plus 4 of 6e to the 2x minus 5x e to the 2x. So this equals d squared of 6e to the 2x minus d squared of 5x e to the 2x minus 4d 6e to the 2x plus 20xd or 20d x e to the 2x plus 24 e to the 2x minus 20x e to the 2x. And if you calculate this like twice, one time, and combine, you will get 0. You will get 0. If we work with the combination of exponential functions, say e alpha x cosine beta x, or e alpha x sine beta x, or a combination, we have repetition, x e alpha x cosine beta x, x e alpha x sine beta x, all the way to xn minus 1 e alpha x cosine beta x, xn minus 1 e alpha x sine beta x. Then we use the inhalator. D squared minus 2 alpha d plus alpha squared plus beta squared to the n power. N is when there's a repetition. If there's no repetition, n is 1. So as you can see, alpha is the power or the exponent of e, and beta comes with the angle, either sine or cosine. For example, for e negative x cosine 2x plus e negative x sine 2x, which what would be the inhalator here to this? Well, look what alpha is. Alpha is negative 1 and beta is 2. So then we use d squared minus 2, alpha is negative 1d, plus negative 1 square plus 2 square. There's no repetition here, so n is 1. So that gives me d squared plus 2d plus 5. So we use this to inhalate that expression in blue. Now, the product, as the last thing, the product of inhalators. So you have more than one, and their product, inhalators, B1, let's say B2, will inhalate the sum of, let's say, y equals C1, Y1 plus C2, Y2 plus So there's like each function or each combination of these functions has an inhalator. The product of these inhalators will inhalate the whole sum. For example, let's say 7 minus x plus 6 sine 3x. So these two go together as one function. It's a polynomial function. Polynomial function. We use d squared to inhalate this because it's a first degree polynomial, so we need a square, like one more. This by itself is a function, one function. Here, there's no alpha. Alpha is 0, but beta is 3. So we use d squared minus 2 alpha, d is gone, plus beta square, which is 9. So for the whole sum, we use the d squared times d squared plus 9. Another example, e negative 5x plus 6x squared minus 5 plus x e to the x. Let's see. What do we have? This one, the middle one, is a polynomial function with degree 2, so d cubed will inhalate this. E to the negative alpha x, so we use d minus alpha, so it becomes 5. And for the last one, it's d minus alpha is 1, and repetition is square. So the product of these inhalators will inhalate that expression. And we'll see how to apply them in the subsequent sections. Apply them even more.